There we go. Okay. All right, so last time we looked at how do we read stuff from a remote website using Scanner, right? Okay, so we introduced Scanner. Scanner will also let us read something in from the user. So if I come in here and I say something like Scanner input is equal to new scanner system.in, and then I say system.out.print, enter your name, something like that. And then I say string name is equal to input dot next line. And I do a system dot out dot print name like that. I'm just going to comment out these for a second. And I run this. It's going to ask me for my name. I'll type in Mike, and it spits it back out, letting me know that it read in my name, Mike. Okay. So we can use that scanner class to read stuff in from any stream. System.in is the stream that's our keyboard. Last time we looked at reading it in from an output stream or from an input stream associated with the URL. Okay, so what we want to do today as a starting point is we want to keep going down this path of object-oriented programming and encapsulation. Right now, if I look at driver's starting to look a little messy, right? We got some details in here and stuff like that. And if you roll back to when we first started talking about object-oriented programming last semester, we used that example of the procedural telephone versus the object-oriented telephone, that pile of wires that looks like that I'm telling you is a telephone, but you see all the details, versus the actual telephone where we believe the wires are in here. But we'd have to crack it open to get to some of those details that we don't actually need to use on a daily basis. So what we want to go ahead and do is we want to create an object that brings these details of reading stuff from a website into it. Okay, so we're going to go ahead and we're going to call this guy our URL reader, something like that. So I'll right click on my package and I'll say new class. And we're going to name this guy URL reader. Okay, remember, objects have fields, constructors, and methods, right? This is a class that we're not going to intend to run, so we won't have main in here. The only class that's going to have main in it in our program is driver. Driver is the program that's going to drive, or driver is the class that will drive our program. That's why I happen to name it driver. You can name it whatever you want. All right, so what I'm going to do now is I'm going to notice this get JSON stuff. It reads in a URL string. So I'm going to actually steal all our code from down here. And we're going to go into this URL reader. And initially, I'm going to create a private function in here. Read from URL. This guy will take in a URL string. So this is effectively the same code we wrote out there. Okay, but we made this guy private, which says you can only access it from inside this URL reader. This is a private interface of our URL reader class. Now, inside of our URL reader class, we're going to go ahead and we're going to keep track of a single field. Let's keep track, well, we'll actually keep track of two fields. Let's keep track of the URL they want to open. And then let's also keep track of the actual stuff we read from that URL in a string. So I'm going to create a private string. We'll call this guy the URL. And we'll also create a private string, the URL contents. Okay. And with that in mind, I'm actually going to have this guy return a void. And you'll see why here in a second. So now we're going to go ahead and create, so all these are private. All these things are only accessible inside of the URL reader class. But now I need to have a way for us externally. What we want to be able to do is we want to be able to, I'm just going to start deleting stuff from out here. Hold on 1 second. Back to where I had my, I want this string before I forget it. So I want to be able to say something like URL reader, let's call it Hearthstone URL is equal to a new URL reader. And I want to pass it the URL that I want it to read from. Okay, this is what I want to create, something like that. And then from there, so all the rest of this I can gut. From there, I can then use my Hearthstone URL reader. Call it like that. I can use that to access the contents of this. So all the stuff, think of this like our smartphone. We know there's wires in here, but when we actually want to utilize this guy, I can do it through this, a single object, knowing that behind the scenes, all those wires are here, right? So one of our goals as a object-oriented programmer is to make sure that our thing that drives our program, main, should look pretty clean. Main should be kind of like an orchestra conductor. It should say like, do this, then this other thing, where we're passing the buck to these other parts of our program that are actually handling the details. All right, right now we get the little red squiggly because we haven't written the constructor yet. So let's go back into URL reader. And we're going to go ahead, we're going to create a public constructor called URL reader. That makes it so that we can access it from within here, within our driver. And this guy is going to take in a string as a parameter, and we'll set this object's URL equal to whatever string was passed in. All right, now we want to get the contents of that URL. And we do that by calling this dot read from URL. And I actually don't need to pass this guy a parameter. I'm going to rename this a little bit. I'm going to call this guy URL string. I'll take it in as URL string because that's the variable I used in here, that variable name. So I'll read in URL string. I will set this object's URL string to the URL string that was passed in. Then I will tell this object to go ahead and read from the URL. I don't need to pass it a parameter because this guy knows about URL string. I would probably write this as this dot URL string right there. Okay. So this object is going to keep track of two private fields. It's going to remember what website did I go to, and it's going to house the collection of stuff it found in that website. Now, before I read from the URL, I am going to initialize the contents of that guy to the empty string. So this is going to get the contents of the URL and fill the URL contents. That's what we want this function to do. So now we call that function, this guy right here, which takes no parameters. He doesn't need one because he already has access to the URL string. And we do the same thing we did last time. We create a URL. This is in java.net. We create our input stream reader. We go through and fill it up. We have line that is actually equal to our answer, but instead of returning it, we're going to say this dot URL contents is equal to line. Okay, So this content here, this method here goes ahead and hits the website, grabs the content, and sets this particular instance of URL reader to the contents of that URL. Make sense? Now I'll also go ahead and we're going to create a public method called display. And we'll just do a system.out.println this dot the URL contents. Presumably that's been filled up with stuff. Okay. And if we wanted, since at the very end here, we actually overwrite the contents of the URL contents with line. Line started off as the empty string, so actually it doesn't make any difference. We can just leave it the way it is right now. Okay, so we will, when we create a new URL reader, we'll set the local URL. We'll set our contents equal to the empty string initially. We'll tell this object to call the read from URL, which goes through and does all this building up. It hits the internet, builds up the variable called line, ultimately sets the URL contents owned by this object equal to that line. And then if we were to call display, it'll just show whatever's in the URL contents. Make sense? So all these wires are hidden inside of this class. When I come to URL or come to driver here, I should now be able to say Hearthstone URL reader dot display, and it should show me the contents of that URL. Similarly, what's the advantage of doing it this way? I can create a second reader. I'll just call this guy reader, and we'll make the website google.com. And then we'll say reader.display. And here's the contents of google.com. This is a smartphone. This is a smartphone. I've created two instances of objects. These objects are the same kind of object, but I fed it a different input. And inside of this object is the logic for going and reading stuff from a website and storing it into a string. Make sense? That's the purpose of creating objects. So that out here in driver, I don't need to worry about the scary wires. I just create an object which reads in the information. In fact, let's say now that I know that this method here works, I can actually minimize it over here. And now it doesn't even take up very much space in there. I'm hiding the wires inside of the detail section. I can expand it whenever I need to, but for right now, I don't need to look in there. So why have it be this big scroll situation? All right, that makes sense why we did this? This is a convenience thing. This is how human beings solve problems in real life. This is why we don't carry around a backpack with a bunch of wires in it when we want to make a phone call. Okay, it's why we think about things in terms of the actual physical objects that allow us to accomplish tasks. All right, so now for us in here, we're not going to worry about this second reader. But what we do want to do is we want to think about the contents of this guy. So this guy follows this thing called JSON, which looks a lot like a Python dictionary. So let's just go this route. So JSON, we probably talked about it last semester, stands for JavaScript Object Notation. So this is how JavaScript represents its objects. looks a lot like a Python dictionary. The reality is it is a mix between a Python dictionary and a list. What do I mean by that? With JSON types, we have something called a JSON object. All right. Now, a JSON object has two forms. Actually, we say it has, two forms. A JSON object can either be a collection of types. This is like a list, or a collection of name value pairs. This is like a dictionary. That's the stuff that goes in there. All right. Now, JSON types are things like numbers, booleans, strings, other JSON objects, so on and so forth, are primitive types, okay, literal type values, decimal or floating point numbers, floats, that kind of stuff. These are the things that exist in JSON. So for instance, let's just give ourselves a simplified example here. If I say examples, we could have a JSON object that just looks like this. Fname, Mike, Lname, even if I put double quotes around it, it doesn't, something like that. That would be a simple JSON object, okay? Notice it even has the curly braces, kind of like dictionaries. Make sense? Name value pairs. Now, another example would be I could have a collection of these guys. I could have one object, and then I can have another object. Maybe this is Dave Smith. I would probably put that all on like that. So there's another example. This is a list of, or this is actually called a JSON array. Called a JSON object for this guy, called a JSON array for that guy. All right, so here's an example of something that's just a JSON object. All right, now let me make a little bit more complex JSON object here. I can have a JSON object that looks like this, and maybe there's a birthday whose value is another JSON object. Month, 1, day, 27, year, 1978. So now here is a bunch of name value pairs, right? The name of this guy is Fname, that's Mike. The name of this guy is Lname, its value is Litman. The name of this guy is birthday, its value is a JSON object, which is another collection of name value pairs. So that might look a little complicated, but what we can abstract this and say, name value is some JSON type. Name value is some JSON type. Name value is some JSON type. This is a JSON object type, as opposed to a string type, as opposed to a string type. Similarly, we could have arrays of these things. So I can have that guy followed by another one of these guys. So maybe this is Dave Smith, and he was born on 3/13/1991, something like that. So that's another example of a JSON array. And we can keep going down the line as we want. We can have objects embedded inside of objects, embedded inside of objects. Go ahead.
So the mic limit will not be bucket 0?
We're not even talking about buckets at this point. This is just how a string is formatted. Ultimately, we were going to want to do something like that, but we probably, just like dictionaries, we would say, give me out of this, out of this object, give me the value associated with F name, which would be Mike. Give me the value associated with L name, which would be Mike. If this is an array, this is the object that lives at bucket 0. This is the object that lives at bucket 1, because this guy looks like a list. He uses those square brackets just like Python does. So we have a list of elements. First element is bucket 0, second element's bucket 1, so on and so forth. All right, so here are just a couple of examples of legal JSON strings. So JSON is just a string. It's a string of characters, but it has to follow the certain set of rules. Make sense? All right, so what's our goal? We want to parse a JSON string into a collection of objects that allow us to conveniently get the information from the string. As a human being, we can look at these strings and see, oh, all the information we're kind of interested in seems to be there. But now, and as a human being, we can look at that and say, oh, I want to know this person's first name. We can just glance at that and say Mike. But if you had to write a computer program that somehow extracts that piece of information out, that might be a little bit more complex, right? Because now you got to start thinking about what algorithm do we have to write to go through this JSON object and ultimately pull out those pieces of information. Okay? Similarly for arrays, so on and so forth. So we have a JSON object, we have a JSON array, and then we also just have a JSON type, which can be anything that is a JSON object or a JSON array or a string or whatever else. Nothing keeps us from also having just a list. So, we can also have here we can have just a variable called numbers. And the value of this guy is 1, 2, 3, 4, or something like that. It's actually 1, comma 2, comma 3, comma 4, something like that. For no good reason, but just this guy also has a field called numbers that just has a list, an array of JSON types in there, and these are just integer literals. Make sense? So JSON is a convenient way of holding information and passing it around. This is why when we hit that website and that website wants to give us a core dump of all this information about cards, it's choosing to give it to us in JSON rather than in some proprietary format. JSON is a known standardized format. It's kind of this the successor to another standardized format called XML. Okay, XML looks kind of like web page stuff where you have opening, closing tags. So this would be like opening first name tag, Mike, closing first name tag, opening L name tag, Lippman, closing L name tag. You start getting a lot more verbose when the actual data you're trying to represent is a lot smaller. So we would call this metadata probably. So we're going to say JSON looks more programming-y with the curly braces and stuff, especially now that you started doing Java and you're starting to see curly braces are something that's based off of C. So if you've been writing code in C or C++, you're already in curly brace world. Python didn't have us use the curly braces. We did it through indentation instead, or indentation instead. But ultimately, we get that there's these block structures in there that hold stuff. All right, so this should look kind of programming-y to us, but at the end of the day, it is structured data. And if we have data that's structured, we should be able to write a program that walks through it and ultimately gives us the ability to extract the information that we want. Make sense? So our actual goal is we want to parse through this JSON string into a collection of objects that allows us to conveniently get the information from the string. So how do we do that? We're going to need to create some classes. We need to create some objects that can take a string, say a JSON string as a parameter, and parse it into its objects. All right. Now I want to go back here and I want to use this guy right here as our example. It's like a slightly complex example because it's showing both the standard JSON object as well as a list, a JSON array. Okay. And we want to think about what this guy might look like. All right. So what is this guy? This guy is a JSON array which contains a JSON object, which contains another JSON object, where this JSON object contains a first name is equal to Mike, a last name is equal to Littman. This JSON object contains a first name equal to Dave, and a last name equal to Smith. That's ultimately what we're dealing with here. We're dealing with a collection of JSON objects. This collection holds a JSON object and another JSON object. Those guys were separated by commas. So if I think about how did I figure out what I was doing here? We're going to be walking through a string one character at a time. Now that's not a big deal, right? You think about just the primitive nature of that. If I come back in here, let me just comment this out for a second. If I say we have the string, I'll copy that. String temp is equal to that. Oh, that's going to make it, it's going to format it funny. Just for the example here, I'll just make it simple. So we'll say A, B, C, D, E, F, something like that. So I have a string that has some characters in it. And if I want to have a loop that goes through all of those characters, I can just write a loop, say for int I is equal to 0, I is less than temp.length, that's the number of elements in temp, I plus plus. And I can do something like system.out.println temp.char at I. This is my way of accessing an individual bucket of a string, temp.char at I. That makes some sense? All right. So when I go and print this out, I'm going to get A on one line, B on another line, C on another line, a space on another line, a D, an E, and an F, all on separate lines. Because I'm taking I on a journey through all the indexes in temp. Each time through, I'm saying, give me the character that lives at index I in that string. So when I run this, you see we have our contents of it. We're not dealing with JSON. We're not doing anything special. I am walking from the beginning of a string to the end of a string, getting one character at a time. Make sense? Okay. How do human beings solve problems? Memory, asking questions, repetition. Here's an example of some repetition here. Here's an example of memory. So I'm remembering some string. I'm going to repeat something some number of times. Right now, I'm not asking any questions. I'm just saying, do this, print out this character. But I could conditionally do something, right? If I look at my example here and I'm walking through this particular string, one character at a time, if I find an opening square bracket, what does an opening square bracket mean? Start of an array. Okay, that's a condition. It's like, I see an opening square bracket. What does that mean? I got to go make an array. And what's the contents of the array? It's everything inside of here up to the corresponding closing square bracket. Make sense? But it's also possible for me to have an array inside of an array inside of an array. So when I say corresponding closing square bracket, I have to be able to deal with the fact that I might have other square brackets in there. But we're going to take it one step at a time, because the farther ahead of ourselves we get, the more intimidating it becomes, right? So right now, I mean, you had the perfect answer there. Right now you said, I see an opening square bracket. What do we know for sure? This is the beginning of an array. That's what we know. And how do we deal with arrays? We probably have a function called parse array. So let's start writing some of this. Now, I'll tell you as a punchline, and you can hate me later, JSON parsers. JSON is a standardized language. Therefore, objects that parse JSON are already readily available. We can go out, we can find a third-party library, bring it in, and just pass our string to that guy. So one of the popular ones is something called simple JSON. That's a Java library. You can bring it in, you can just create you say, I think it's JSON simple, name your variable equals new JSON simple. You just pass it the string that's your JSON, and it will give you a single JSON object that has all the crap in it, ready to use. Give me the first, give me the collection, give me the bucket zero's first name, so on and so forth. But I say to you, what fun is that? Wouldn't you prefer to just write your own parser? Really feel like you're not taking advantage of somebody else's hard work, especially as we're trying to learn how to do this stuff. All right, so we're not going to use somebody else's JSON parser. Java also doesn't have a built-in JSON parser as part of the language. A lot of modern languages do, Python does. But there's plenty of libraries out there that allow you to work with JSON. Java does have a library called serializable, which is something else that allows you to move between objects and objects that you wrote. You can convert them into JSON and vice versa. And at some point, we'll probably see that, but unimportant to us right now. For us, we're not allowed to use external libraries to do this. We're going to write our own. This is an exercise in string manipulation, right? And those are the kinds of problems that we like. We did a bunch of them last semester. We're going to do more here. So unfortunately, we won't use any of them. We will just write our own, because we can. All right. So we're going to create a collection of objects here. What objects do we need? Well, we need a JSON object, which is a collection of, actually a JSON object is one of two things. It's either a collection of name value pairs or it's a JSON array. One of those two types, okay? So at the end of the day, everything is a JSON object, but we can have a specialized version of a JSON object called a JSON array. So why don't we say this? We have a JSON object, and off of JSON object, we have something called a JSON array. And we also have a JSON, maybe pairs. This is kind of that inheritance model. Remember from last semester, we had like the player class and we had a monster class, and those things all were inherited from each other when we were working with objects. So we might have a top level object called JSON object. And off of that, we have two different kinds of JSON objects. We either have JSON array or we have JSON pairs, where a JSON pair would be the opening curly brace guy. So these are the guys that start with this. A JSON array would be these are the guys that start with that. Make sense? And we can say that the top level object is always one of these. So no matter what we do, we're going to be dealing with something that is a JSON object. Our example back here, this guy is a JSON object that is of the form JSON pairs. This is a JSON object that is of the form JSON array, which contains two elements, bucket 0, bucket 1. First element is a JSON pair. Second element is a JSON pairs. Make sense? Okay. So at the end of the day, after we call our parser and tell our parser to parse, it's going to hand us one JSON object and say everything you need's in here. And then you can use that JSON object to get at the collection, the array, or to get, if it's a JSON object pairs version, you can say, give me the value associated with, from the array, give me bucket 0, and give me the value associated with first name from that JSON object, something like that. All right. So we're going to have a JSON object, we're going to have a JSON array, we have JSON pairs. We're also going to have our JSON parser. This is the top level tool that takes in the JSON string, parses it, and hands us a single JSON object with everything in it. All right, make sense? Those are the three things we're going to need to do this. So far, as long as we don't think about the complexity of it, so far, not too bad, right? I only need to create three things. One of them starts with curly braces. One of them starts with square brackets. That's not a big deal. All right. So really, I guess it's four things, right? We have a top level guy. We have an array version of him. We have a pairs version of him. And then we have this supporting, this is kind of like the machine, okay? This is the machine you dump your string into, and he gives you one of these as a result. Okay? So what is a JSON parser? Start from the bottom. JSON parser object. This guy reads in a string in JSON. Well, this guy is constructed with a string that is in JSON format. He parses that string into a series of JSON objects and ultimately returns a single JSON object that is the parsed result. So that's what JSON parser is. So if we go and we start writing that, I'll just right click on my default package. I'll go to new class. We're going to call this guy JSON parser, like this. And we'll create a private string called this guy the JSON string. And we're also, well, for right now, I'm just going to leave it at the string because we don't have time to quite get into the parsing yet. We'll start writing that on Friday. Then you'll have a homework assignment over the weekend to write a little bit more of that. All right. So then we're going to write our constructor, public JSON parser. This guy's going to take a string as a parameter. And we'll set this dot that guy equal to that guy. Then we're going to have a public. For right now, I'm going to have it return nothing. We're ultimately going to have it return a JSON object. Okay. And this guy will be called parse. His job is to parse through a JSON string and return a single JSON object. That is the parsed version. So all the magic happens in here. Make sense? I'll put a little comment here. We'll eventually return a JSON object. Now let's go ahead and create our other pieces just as starting points. So we'll say we have a new class. We're going to have a JSON object. All right. And for right now, I'm actually not going to put anything inside of this class. I'm just going to have it exist for right now. Because realistically, if we look back at the notes here, we likely will never ever have anything that is just the generic JSON object. They will always come in one of two forms, either a JSON array or a JSON pairs. Make sense? Those are the two actual forms that will exist. Next class, we're going to talk about abstract types, but for right now, we're just going to leave this guy like this. I'll also go ahead and create my class JSON array. And we're going to say that this guy extends JSON object. Similarly, we'll create our class JSON pairs. And we'll also say that this guy extends JSON object. So JSON pairs and JSON array are both JSON objects. So next class, we'll say, we'll actually make this guy abstract. Let me just put in the notes here. Start with abstract. Say that. All right, so we kind of have ourselves teed up. We're getting ready to write this parser. And so next time we're going to start writing some tedious logic that's going to allow us to walk through this, but it's also going to be very algorithmic, and it's ultimately just walking through a string, building things as we go. All right, questions, comments, concerns, bribes. No homework for Friday, but we probably will have some over the weekend. All right, I'll see everybody on Friday. Stop. I gave you the URLs and the